Today we are doing our last lesson of Unit 2, Angles and Triangles, and it is Unit 2, Lesson 8, AAS, or you can flip it around, SAA. Be careful, it's not a bad word. 2 A's and an S. And so go ahead and get this down in your table of contents and flip to a new page. And with any luck, I gave you this to take home with you last class. And so what we're going to do today is eventually we're going to take notes in here and then we'll glue it in. It's just one page, but I folded it so that it would fit. And the date, you write your date, the lesson, the essential question, what does AAS tell us about triangles? And then we'll have to use the space over here for our summary because there won't be room at the bottom. But I'm going to write in my book before I glue it in. Otherwise, I have to deal with this annoying like crease situation. So I'm going to write in it first and then glue it in. So, I should have given you a moment. If you want to get this down now, go ahead and pause and get that down. So today we're learning about our last triangle congruence shortcut, which is AAS, or angle side. And so let's sketch two really quick triangles here. Okay, two triangles. And what the angle side triangle congruence theorem tells us is that we really only need two angles. So maybe these angles are congruent and maybe these angles are congruent. And we already know that if the side between them is congruent, the triangles are congruent. And that would be by the shortcut angle side angle, ASA. But this one means that the side that we know about is not between them. It's some other side. So in this case, it could be either these two sides or these two sides. Be careful, you can't have one of each, right? So if I know the length of that side, then its corresponding part would be the one across from one loop, right? So I need to make sure that it's congruent with that side. And in this case, I have congruent triangles because I have two angles that are congruent and then a pair of corresponding sides that's not between them. So we've got angle, angle, side, angle, angle, side. So that's what the theorem tells us. And by itself, this isn't hard. What's starting to get hard is that now we know really 5 different triangle congruence theorems, and we have to be able to identify which one is used in each situation. So that's really what this lesson is about today. We're going to go through a whole bunch of examples, and they're all printed for you, so it's not that much writing, but it is a lot of examples. And we're going to try to figure out, number one, are the triangles congruent? And if they are, what is the theorem that tells us so? And so here I've listed all the triangle congruence theorems we know. CPCTC means corresponding parts of congruent triangles are congruent. That's if you have 6 matches. We're not really going to see that because that's not a shortcut. ASA is 2 angles in the included side. Side angle side is 2 sides in the included angle. Side, 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 and then the one we just talked about, angle, angle, side. So let's look at example 1. For this one, I'm already kind of stumped because I see one pair of corresponding angles that are congruent and one pair of corresponding sides, but that's not enough. I need 3 corresponding congruent parts to make one of these shortcuts work. So I hope you can see that there are some vertical angles here. So what I would like for you to do is mark the vertical angles, mark that they're congruent. So these two are across from each other, and that means they're vertical angles and they're congruent. So 2 loops, 2 loops. And the reason I need 2 loops is because the one loop is already used up. So here we've got 2 angles and a side. And so I know when I look up here, it's either going to be this one or this one because those are the only shortcuts that have 2 angles, right? 2 angles, 2 angles. So I just need to see, is the side that I have in between them, like an ASA, or is it not between them, like in AAS. And in this case, it's between them, right? This side that I know about is between the two angles. And so the shortcut is, well, first we're going to say congruent by angle, side, angle. I've got two angles and a side. The side is between them. Let's look at example 2. In example 2, I again have vertical angles, so please mark them. In example 2, I have two sides and one angle, and so I'm going to look for a shortcut that has two S's and one A, and that would be this one. So if this shortcut applies, then I know my triangles are congruent. So I have side, side, and the angle in between them. And that's exactly what side angle side says. Two sides and the angle between them. So these are congruent by side angle side. So far I've got two congruent triangles. Let's look at example 3. Okay. Example 3, I only see one pair of angles marked and one pair of corresponding sides marked, but I hope you see there's another side that's sort of hidden here. And that would be this side. We've talked a lot about this when we do proofs, the reflective property of congruence, reflexive property of congruence tells us that this side, because it's shared by both triangles, has to be congruent to itself. So here I have two sides and an angle, and so coming up here, two sides and an angle, my only option is this one, side angle side. And to use this shortcut, I need to make sure that the angle is in between the sides. And so looking here, here are my two sides. This is the angle between the sides. So the shortcut side angle side doesn't work here. What we have here is we have angle, side, side. We have angle, side, side. You guys, that is a bad word, and it is not a triangle congruence shortcut. So if you get the bad word, you should cross it out. You should probably erase it so your parents don't see it and wonder why you're writing bad words on your math work. But this is not a triangle congruence shortcut. So if you have something like that, these triangles are not congruent. Okay. Example 4. What I'd like you to do, there are 3 more examples here. I want you to pause the video and try them on your own, because if you just copy down what I'm doing, you are not going to really learn it. So go ahead and pause the video right now, finish these on your own, and then check back in to see if you got them right. For real, pause. And we're back. So in this example, I again have the reflexive property of congruence, that this side is congruent to itself. And here, I've got two angles and a side. So my options are ASA or AAS. In this case, the side that I know is not between the angles. Angle, angle, and a different side, not the one between them. And so that would be angle, angle, side. So they are congruent. Okay, looking at example 5, I got interrupted there. Sorry for the jumpy video. All right, example 5, we have two triangles, and we're trying to determine if they are congruent. So we hopefully can see that that side is congruent to itself in both triangles. And so I've got two sides and an angle. So looking at my options for two sides and an angle, there's only side angle side. And the issue here is that this angle is not in between the two sides that I have congruent. So this is another bad word one. This time we'll write it that way so it doesn't look like a bad word. But we have side, and then the next thing we see is a side and then the angle. The angle's not between them. That's not a shortcut. So we're going to say not congruent. Last one, example 6. We have some hidden vertical angles here, so I hope you marked those congruent. And so I've got two angles and a side, so two angles. And then the question is, the side that I have, is it between them? If so, I would squeeze that in here, or is it off to the side? And in this case, it's not between them. This is the side between the angles. That is the non-included side. So it would be angle, angle, side, and so they are congruent. go ahead and open up your book, and we're going to talk about a different type of problem that you might see. So this says, write and mark what additional information would be needed to prove that the triangles are congruent by the given shortcut. So in each of these examples, you don't have enough information to know they're congruent, and I'm saying, what else would you need to know? What else could I mark on here to convince you that the triangles are congruent? And so I'm gonna use a pencil here and not a marker, because I'm gonna mark stuff and then I'm gonna need to erase it as I go through. So first, by ASA. Well, in this example, I have an angle and I have this shared side. So I already have an angle and a side. If I want to use ASA, the key is that the side has to be between the angles that I know. And so that means I have to know another angle, but the angle has to be over here, because it has to be, the side that I know has to be between the two angles. And so if I'm going to show that they're congruent by ASA, I would need to know something. I would need to know that those two angles are congruent if I'm going to use ASA. And so when it says what additional information would be needed, you would say you would need to know that angle DUT, that's this angle here, is congruent to angle SUT. If you know that, then you know that these triangles are congruent by ASA. Now over here we have a totally different problem, so I'm going to erase that. I should have done this one in marker, because that will always be true in this problem. Over here it's saying, okay, well, what if you wanted to prove that they were congruent by side angle side? Then what would you need to know? In this case, it's the angle that's between the sides. In this shortcut, we only know one angle. Here's the angle. So I need another side, but I need to make sure that this angle is between those two congruent sides. And so I hope you can see, excuse me, that the side would have to be this one, because I need to make sure that that angle is between the two congruent sides. And so if I'm going to use side angle side, this is what my picture would need to look like. Side angle side, side angle side. And so the information needed would be that side DT is congruent to side ST. If I knew that, then these triangles would be congruent by side angle side. So I'm going to erase that and move on to the last one, which is by angle angle side. So in angle angle side, I need two angles and a side, but the side this time cannot be between the angles. Not between the angles. And so I have an angle and a side. I need another angle, but I have to make sure that wherever I put it, this side is not between the angles. So this time, don't put it here, we're going to put it up here. This way, I've got angle, angle, side. Angle, angle, non-included side. Angle, angle, non-included side. And so to write this out, we would need to say that angle, I'm going to say UDT, would have to be congruent to angle, this one down here, UST. So I'd like you again to pause the video, complete examples 8 and 9, and then check back in to see if you got them right. Okay, guys, we're back, and I'd like you to just check your answers here, and if you got something that I didn't get, or if what I have doesn't make sense, I want you to go back and look at it and see if you can figure it out. One note is that in these examples, I was able to name my angles a lot simpler just with one letter, because the triangles aren't kind of overlapping, and that makes it for sure easier to write. And so go ahead and pause this, check your answers, and then we're going to move on and do this proof together. So your favorite proofs. It says complete the proof, and then what I'd like you to do is, I know I'm having you do a lot of pausing in this video, but the only way to get good at these proofs is to try them on your own. And so I want you to do the following. I want you to go through what's given and mark what's given. And then I want you to think through on your own, how are we going to prove that these triangles are congruent? And I want you to have a plan in place before you start your proof. At that point, feel free to unpause the video if you want to do the proof with me, or if you feel really confident, go ahead and complete the whole proof on your own. So at this point, pause, get as far as you can, and then check back in. So it says here, angle PQU is congruent to angle TSU, and that's already marked for you. It also says QUR and SUR are right angles, so I'm going to mark that one. And we're trying to prove that these two triangles are congruent. So right away, I hope you see we have an angle pair, and we also have that guy, right? And that is part of both triangles, and so we know by the reflexive property of congruence that we have a side pair. So I guess where I would go is, like, we don't have any evidence of any more sides, but I do have some angles. It's just that they're not actually inside the triangles. And so I want to think about what I can deduce about this angle here and this angle here. And one thing I know is that these two angles combined, right, this one and this one, form 180 degrees. That's a linear pair. I also know that this angle and this angle are a linear pair. They form a 180-degree angle. And so because these angles are the same, when I subtract this from 180 to get this, it's going to be the same as when I subtract this from 180 to get this, because these are the same angle measures. And so I know that those are going to be congruent. And so I do have two angle pairs and a side. This is the non-included side. And so I already know that my final reason here is going to be angle, angle, side. Angle, angle, side. And now it's just a matter of having to prove it. And some of this stuff is pretty straightforward. We're going to start by writing down what's given. Angle PQU is congruent to angle TSU, and I know that because it's given. So that's statement one. Statement two, I'm just copying from up here. Okay, so that's what's given. We need two angle congruent statement and a side congruent statement. So I'm going to start with these angles. So this will be statement 3. And I want to be able to say that those angles are congruent. It's these two angles that were listed here. So I'm going to say angle QUR is congruent to angle SUR. So that's my first angle congruent statement. I didn't really leave myself a lot of space, so I'll just put my A there. And why do we know that? Well, we know that because they're right angles, and we know that all right angles are congruent. Okay, one down, two to go. This is pretty easy here, this side statement, so let's work on that. I'm going to say here that side UR is congruent to side RU. And we've done this a lot of times, right? That side is in both triangles. And the reason you could write, it's totally fine. Oh, what happened here? This should be a 3. It's totally fine if you just write same segment. But it's also good to know that the official term here is the reflexive property of congruence. So I have an angle and a side. I just need my last angle. And the reasoning here is kind of challenging, so we're just going to try to put into words what we talked about. I'm going to go ahead and write my congruence statement. Angle UQR, that's this guy here, is congruent to angle USR. And how did we know that? Well, we know that because they're both linear pairs of angles with the same measure. So that's what I'm going to write. They're both linear pairs of angles that have the same measure. And you might have a different way of saying it, or maybe even a better way of saying it, but ultimately we're going to find these angles by taking away that from 180 and that from 180, and those are the same. So we know we're going to end up with angles that are congruent. So that's my third angle, or my third congruent statement. And so I'm ready now to write my proof statement. We were supposed to prove that triangle RUQ was congruent to triangle RUS. And be really careful, because the way that I ordered them here, it looks like ASA, but keep in mind that the side is not between those angles. And so the reason here is actually angle, angle, side. So if you were able to get even part of that, congratulations, you are a master prover. If you're still struggling with these, you're not alone, so just be patient with yourself. And that, guys, is the last video for the unit.